Peterson Gary, working at Kenya Meteorological Department at the data management section. I want to take you through 3 aspects of a climate data tool. This is data extraction, data aggregation, and data regridding. So I'm aware that you already know how to use a CDT data tool, and you are able to prepare data into CDT data format. So let's start by opening our CDT. Go to data preparation and pick data extraction. Here you'll find that there are various things that you are supposed to define. Among them is the timestamp of the input data. So we shall be using netCDF data, and we shall use 3 approaches to extract data. One of them is using shapefile. Another one is using CDT coordinate file, and you can simply define a single point. So let's start. My data in netCDF is in a daily resolution, so I'll pick daily data. Alternatively, you could be having data in hourly timestamp, or pentant, monthly, annual, or so forth. So in our case here, we shall use daily time stamp. Once I define that, then the format of my data is in netCDF gridded data. So I will navigate to where my data is. In my case now, I'll use charts. You could use rainfall data, temperature data, and so forth. So for demonstration purposes, I'll use chart. So I'll click on chart and select that. So you see it has come into this field here. But always remember that whenever you input a netCDF file, you need to do the settings. So I'll click on the settings and then input a sample file so that the application can be able to understand the data format of that file. So once I do that, I need to define variables, longitude and latitude. So I'll start by defining variable, and my data has one variable, which is rainfall estimate. Then my longitude is long, and my latitude is lat. Once I do that, I click OK. And then something which is very important is to define the file naming format for the data that we have input. So the field in here is the naming convention of the data that we have input into the application. So it needs to match, I need to match that with the raw field. So I'll copy that part of the file name and replace it here. And once I ensure that the top filing format is similar to this convention, with the first part being the definition of the year, the month, and the day, I'll click OK. So essentially, I've defined all the parameters that are required by the netCDF file. So the next field here, if I'm using a shapefile, I'll click in here and check in my shapefile. So here I'll use Kenya sub-counties shapefile. I'll click in there and open. You see now the fields are populated. But something to keep touch on is the attribute of the shapefile that you have input. So if you open in there, you'll find that you have various levels that are defined by the shapefile. Among them is administration level 1 and administration level 2. In any case, you can still open the attribute table of the shapefile that you have input, and you can see that you have names for the administration level 1 and another set of names in administration level 2. So it is upon you to choose what you want to extract with. For instance, I will be extracting my data using administration level 1. So I'll click in here and input administration level 1. So once you have done the input parameters, then there is the second menu here called location. Location is where you define how now you want data to be extracted in terms of either it is a point or a polygon. And remember, since we have input the shapefile, shapefiles are polygons. And our shapefile has multiple sub-polygons inside it. So we shall use multiple polygons. And then once this menu is populated, I shall get all the polygons. And you can see in here, we have a set of many sub-polygons inside there. So I'll click OK, and there I have my sub-polygons. Once I have done that, I'll do the output. The output is where you define the date time, the range in which you want your data to span from. Remember, you need to know how your data is in terms of it is from a start date, in a certain start date to a certain end date. So we can check that before we input. So in my case, I've put my data into this folder called CDT video smaller dataset, and the data that we are interested in is CHAPS, and it is spanning from 2011 to 2020. So having that in mind, I can be able now to spell out this date time range. For instance, I could be just interested with data from 2015 maybe to 2016. This is January 1st to December 31st, and then say OK. So months to extract, you could be interested in having an annual data set from January to December. If it's seasonal, you can input March to May, also desired. And our output file format is CDT, station data format. This essentially gives you a CSV. It is very important to know the particular type of method that you are using to extract data. And in particular, if you are using shapefile, it will always be multiple polygons or one polygon. If you are using a CDT coordinate file, it will be multiple points. And if you are only using 1 point, you can easily choose 1 point. So in our case, we choose multiple polygons, and we were able to input all those polygons, sub-polygons within the polygon. So we continue now to define the date time range. This is like from which date to which date, end date to where the data is starting. So we have seen that our data span from 2011 to 2020, and therefore we can try to extract only 1 year data for the sake of demonstration. For instance, we can put 2014 January to 1st, because our data is in daily timestamps. So 2014, and then we say OK. We define the CDT station data format. In our case, we want CDT station data. This will give you a CSV format, and then we define where we want our data to be saved. We could say precip. This is rainfall data, precipitation, extracted, maybe from 2014, and then we say save, and then extract. So here you'll see the percentage, and the application will tell you whether the extraction was successful or not. So if we go to where we have saved our data, we called it precipitation extractant 2014. We can open it, and we see that our data was extracted as per the sub polygons, that is at the main level 1, and this is the data, and therefore you can be able now to use this data in other applications. So that is one method. So we have used polygon to extract our data. So I will demonstrate now how you can use a coordinate file to extract data. Let's try to examine what is a CDT coordinate file. I had prepared one here. So this is a typical CDT coordinate file. It has a station name, station ID, longitude, and latitude. So what is very important here to note is that longitude will always start before you define the latitude. Once you have done that, then you can be able to use your CDT coordinate file. So let's go on and use that. You can clear your CDT, or you can just decide to continue. So in my case, I'll try now to clear this and initialize another CDT instance. Then again, I'll use the same menu, data preparation, then data extraction. Our data is still in the daily time step or resolution, and I'm using netCDF gridded dataset. I will still demonstrate using the charts, and once I select that folder, I need to do the settings. Always do the settings. Give the sample file. Once you give the sample file, you need now to define the variable longitude and latitude. Once you make sure that you have defined these parameters well, you say OK. And then here again, you need to spell out your file structure by copying that part of the name and pasting it there, and ensuring that year, month, and day actually corresponds with the number of these special characters here. And then once you ensure that everything is fine, you say OK. Now we are not using shapefile, so we'll skip this for now and go now to location. Once you do the location, our coordinate file has several multiple points, so you pick on multiple points. Immediately now the application prompts you to browse where you have your CDT coordinate file. So you can use a CDT coordinate file or an existing CDT station data format. So in my case, I'll go and browse where I have kept my coordinate file. It is in here. I pick it and open it. So it requires me to input some of the things, to define some of the things in here. So for instance, my coordinate file is in comma delimited values. So I'll choose comma delimiter. And then the first row of my data is headers. For instance, the first row defines station ID, station name, longitude, latitude, and so forth. So you need to define what your first row is. And I say it is true because the application will need it to evaluate the data. So I say OK. And you can see these are the points that I want now to extract data from. And then I say OK. Once I have set that, I need to do the output. This time I could be interested with data from 2015. Remember our data span from 2011 to 2020. But for the sake of demonstration, I'll just pick a smaller data range so that it doesn't take a lot of time. Maybe 1 year, and say OK. Again, our data is in CDT station data format, and then where I want to save. I'll call it precip extracted 2015, and then I say save. I do extraction. So the application will prompt you whether the extraction has been finished successfully. In our case, it has been successful. So we can go now to where we have saved the data and examine. So it was precip extracted 2015.csv. We can check and see now these are our station IDs and this is the data. So those are the two approaches that you can use to extract data. And the other one is just inputting a point, just inputting the longitude and latitude, and then you are able now to follow the same procedure. If you are interested with only a single point, you can input the longitude there and latitude there, and then you extract. Otherwise, that is all for the data extraction. I'll be taking you now through to the next agenda, which is data aggregation. So let's see how we can be able to aggregate data from daily to other resolution. For instance, you could be having data from daily and you want it to get aggregated to decadal, or daily to monthly, or even monthly to annual, and so forth. So let's get started. So the same menu, data preparation, you go to aggregating data, aggregate data, aggregating time series data. So you click on that, you get a menu like this. The first thing you need to define is whether the data is daily data or hourly data or so forth. So in our case, we want to aggregate data from daily data to monthly data, for instance. So our data is in CDT station data format, and we need to go and pick it up. We can pick the same data that we in the extraction earlier on. This is a precip extracted 2014. We need to say whether this data is command limited and so forth. And because this data is now in CDT data format, our first row is false. This is a station ID and not station head, or rather not file headers or column headers. So it will remain false. And then we say OK. Aggregation parameters. Since this is rainfall data, aggregating it from daily to monthly will be summing up. We shall be trying to get a total out of the daily observations. If you are aggregating temperature, that is a different thing. You need to do a mean. You don't total temperature values, you do an average. So in our case, because it is rainfall observations, we do summation. So there are other options here: sum, mean, median, standard deviation, and so forth. So I pick sum, and then I say OK. Once I do that, I'll check my input, like it's daily to monthly, and then I'll spell out where I want this data to be saved. So I'll call it monthly data, and then save. Once I save, I say OK, and then I run. So you see it's very fast because it was only 1 year. Again, we can always check what we have done. So our monthly data is in here, and now you can see that you have year 2014, January, February, all the way to December. So in essence, you have aggregated daily data into monthly timestamp. So for instance, if you want now to aggregate the same to annual or seasonal, you can be able to do that. If it is annual data, you can say daily to annual, and then aggregation method is sum, and again now you spell out where you want now to save. You can say it, you can do it like that, annual data, and then you say OK, and you run the application. Let's see what we have for the annual data. So we have one column. So these are annual totals for all these stations. So aggregation is quite easy. You only need to know that your data is in CDT data format. You only need also to be clear on what you want to do, if it is from daily to seasonal to annual or to whichever times table you want to do. Of important is to know that precipitation will always be summed because you are more interested with the totals. For temperatures, you could do averaging and so forth. So that's all for the aggregation. We shall now delve into the other thing. This is data regridding. Regridding simply means that you could be having data from 10 kilometer resolution, and you want to regrid this data to a finer resolution, maybe 5 kilometers resolution and so forth. So let's see how to go about it. So again, it's the same menu, data preparation, then regrid spatial data. So this is spatial data. You could do one in a CDF file. For instance, we can pick one. I'll pick one of the files here. For instance, I can pick chap here. Once I pick the chap, I'll define the settings. Immediately I input the settings, I'm able now to see the resolution for this data. And the resolution is that it is 0.05 degrees. This is basically like 5 kilometers. The span is also spelled out. And therefore, I can continue to link grid this data maybe to 4-kilometer grid. For instance, I can pick the grid from another existing grid, get grid from another netCDF file. Let's see. So I'll pick it from timesat. I end timesat somewhere. This is a dem. I'll use timesat. Timesat is 4 kilometers resolution. I'll pick that. I'll now define its settings. Always, whenever you put netCDF file, you need to define the settings. That's fine. Once I input the file that I want to get grid from, then I can now say where I want this file to be saved. For instance, I can say regridded chap like that, and say OK. Select that. I say OK. And then run that. So let's see now whether the file that we regridded from 0.05 kilometers, how many degrees, is now changed to another resolution. So I'll go from the data preparation, regrid. I want to regrid only one netCDF file. Remember, you can do multiple files as so desired. If you have several of multiple netCDF file, you can be able to input that as well. But for the demonstration, I want to demonstrate using only one netCDF file. Then I will input the netCDF file that I want to regrid into smaller resolution. So in my case, I'll use this test, which was 0.1. I'll set up the netCDF setting parameters. I'll say OK. You can see it is 0.1. Then now, this time I'll use now grid from another netCDF file. So I'll pick netCDF file. I know my chaps are usually 0.05. So chaps, I'll pick one there. I open. I'll set up now the parameters as well. Like that. Then I'll say where I want this to be put. Maybe I can just put it, can create another folder there and say regridded data, like that. And then I say OK. So this is done. I can now check whether my 0.1 is regridded into a chap resolution. So I'll go now to daily preparation again, regrid data. I'll go and pick it. We called it regridded data, gridded, and here it is. I'll set up the settings. And I can see now our 0.1 is now 0.05 resolution. Thank you for your attention. And I implore into you all, encourage you to keep on practicing these things, because you see the CDT has power. We have not exhausted all the menus. You can only become competent into the way you can do analysis by trying many menus on how to manipulate a netCDF file, CDT data file, and so forth. Thank you, and God bless you.